today. I don't think anybody saw it. I think I got to it early enough, but I had a full assignment. I actually stayed up last night making 2 assignments. The Wednesday one is like saved. It's not in this period. Actually, I'm on freeze, so I'm in the wrong thing. But I had an assignment for today and Wednesday put up in Google Classroom, but I had to go in and take them down. Because we got a new thing today. We got sapling logins. So everybody close your Chromebooks. I'm going to go through the PowerPoint real quick, and then I'm going to go through how to log into sapling for the very first time for everybody here and at home. And we should be good to get that first assignment done. The first assignment is only 6 questions, so it's not going to take you very long. The assignment tomorrow is more questions. It's 22, which sounds like a lot, but they're pretty easy. It shouldn't take you too long either. But I'm going to do the lecture for both of them today. So tomorrow you don't have to listen to a lecture and do the assignment. You can just do the assignment. So let me go to my P drive, chemistry, SL. Come on. Open. Scroll down, and I'm looking for, oh, there it is. What is science? It's going to open. Yeah. It's not there, right? This is terrible. I need to calibrate my pen, I guess. There we go. I saw the little weight thing. Hey! Huzzah. So we went through the what is science yesterday. Today we're going to go through the hypothesis side and the theory side. Y'all are probably already familiar with this, so I'm not going to spend a whole bunch of time talking about this. But we are going to go through the presentation just in case. So we went through the what is science yesterday, and you can check out that video if you need to go back over it. Now we're going to start with a hypothesis. So the first thing you need for any hypothesis is an observation. You have to be able to see something. You have to be able to ask a question. They're going to make a point that your hypothesis probably has to do with one of the 5 senses. You hear something, you see something, you feel something. Why is this table smooth when the wood is a little bit rough? Anything can kind of matter. Like one thing, no, I won't talk about that yet. Maybe later in the semester. Smell is a weird thing. Like what are you smelling? What is happening when you smell something? Particles of that thing are going in your nose and hitting the receptors, and your brain understands that. And so there's a lot of science to be done with your 5 different senses. So you got to make an observation. You got to see something. You have to form a question out of that. There's other things that can help us. As they say, if you have a telescope or a microscope, that can help your sense of sight see things that you wouldn't normally be able to see. So observation is the first step in any scientific inquiry. You have to see something before you even get to the hypothesis phase. Then once you ask a question, once you're trying to figure something out, you can develop your hypothesis. So what is a hypothesis? A proposed explanation for a set of observations or natural phenomenon. It's your, like we say, best educated guess as to what could be happening or why something is happening. So they have that here, educated guess. I don't really like the guess part. I mean, it is kind of true, but don't really think of a hypothesis as just guessing. It's more than just guessing. The educated part is very important. Or it is a prediction based on other scientific data or knowledge. So sometimes you know a lot about what's going on. You go out in the morning, you try to start your car doesn't start. It's not like you don't know anything about your car. If it turns over, if the battery's working, it's trying to start your engine, but it's just not starting, and you know from your knowledge of previous days that, oh yeah, I haven't been to the gas station in like 2 weeks, and something y'all need to get used to when you start driving, because everybody kind of goes to this phase, you don't look down at your gas gauge. You're just driving. You're listening to the radio. You're hopefully paying attention to the road and looking out for other drivers, and sometimes you just forget to check the gas gauge, and you're like, oh yeah, I haven't looked at that in like a week. And then you go out to start your car, and your car doesn't start. You can form a pretty educated guess that you ran out of gas, and your car's not starting because you're out of gas. That's not just a like random guess. That's an educated guess. You have a lot of data that's backing that up. And so treat a hypothesis more than just some random guess. It must be testable. In this example, can you test to see if you're out of gas? Yeah, you can literally go get gas, put it in your car, and see if it turns on. Or you turn the key on. Some cars, your gas gauge will work whether the car's running or not. You turn the key on, your gas gauge doesn't go anywhere. All the lights come on, but your gas gauge just stays at the bottom. You're out of gas. That's your problem. Must be falsifiable. Is there an outcome where my car's not starting, but my gas tank is full or half full? Yeah, it could be all sorts of other things. So you turn that key and your gas gauge goes up to like halfway or a quarter tank. You know that you're not out of gas, so it's got to be something else that's keeping your car from starting. So this is a good testable, falsifiable hypothesis. And it's not just limited to science. We do this in everyday situations. You don't have to be a scientist to use hypotheses or the scientific method. I gave an example for your car. That's an everyday kind of thing. So people continually form and test hypotheses every day. An example, you turn on the light switch and the light does not come on. This is actually kind of an interesting thing. I had a job interview where they asked the big companies are getting crazy now with their job interviews. They don't sit down and they're like, yeah, so do you like this job? Do you want money? Are you a hard worker? Like anybody's going to be like, no, I'm really lazy and I hate to work hard. If you hire me, I'm probably just going to hide in the back room and try to avoid doing work. No one's going to say that in an interview. So I had them, they said, you go into a room and there's a light switch with 3 light switches. Just all in a row. 1, 2, 3 light switches. The light switches control lights in another room. You can only go through the door once to the other room. So you can mess with the light switches. You can't see whether they're turning anything on or off or not. But there's 3 lights in the other room, and you get to go through once. How can you figure out which light switch works with which light? And so you kind of have to like think about which ones you would flip and why they would mean that they correspond over there, because you can't turn all 3 of them on. So you turn all 3 of them on, you go in the room, you still don't know which one goes with which. So you kind of got to like just think about a plan of how you're going to show them that you can figure out which light switch goes with which light switch with only going through the door once. So hypotheses don't always have to be real life things. They can be like mind games that people play with you. So the bulb is burnt out. Test it by replacing the bulb. If you put a brand new bulb in, that could be that that was the problem and it fixes it. Or you put a brand new bulb in and it still doesn't turn on. Maybe you have a wiring issue. Maybe you got rats in your ceiling or squirrels in your ceiling and they chew through the wires, because you don't let squirrels in your house. In the trees, that's fine. But if you're chewing on my house and you get in my attic, we're going to war. Like I said, it could be a wiring problem that's keeping it from coming on. Your doctor's patient has a sore and an inflamed throat. Is it strep throat? Is it the flu? Do you have the coronavirus? Which this was written before the coronavirus, so it's not even on here. But there's lots of different things you can do. You can do a throat culture. How do they test for the coronavirus? Yeah, they're like all the way into your brain, not really into your brain, but way up your nose with like a Q-tip, and they swab the inside. Because just the edge of your nose, they're not going to get enough bacteria to actually make a sample and get a positive case. So they got to jam it like way up your nose to actually get a positive. Observations. Sunflowers grow taller in a sunny area than sunflowers in a shady area. Y'all can see this just driving down the road sometimes. We got a lot of farm fields around here. And this school year, there was a sunflower field not too far down the road towards Waxahachie. There's also people growing, is it sorghum? It's like that nice like red grain that was up on top. You should be interested in what people grow around here. It's actually pretty cool. It's way better than parking lots and brick buildings. So you form a hypothesis. The direct sunlight stimulates growth, and I'm pretty sure sunflowers are cool. They follow the sun. Like they actually turn during the day to be looking at the sun or away from the sun. Test. How can you test this? You grow sunflowers in different areas. you see is the one that's getting the most sun growing bigger, or is it something different that's going on?
Good morning. New kid in town. Following students need to report to the gym. Sierra McCarty, Emily McKissick, Preston McLaughlin, Dylan Medina, Christian Mendoza, Austin Michael, Weston Miller, Alyssa Montito, Luis Morales, Arabelle Morgan, Elijah Morgan, Jared Mosley, Mike Moya, Marissa Munoz, and Cassandra Munoz.
All right. So for the online students, they're doing drug tests today. So I guess if you come back at some point in time, you got to do that. Or maybe, I don't know, maybe you miss out on it. Who knows? So we're talking about hypothesis. Your hypothesis must be supported or not supported by observational data. It's got to make sense. If not supported, it's false, and you reject it. And maybe you're just done with it then. You move on to something else. Maybe you have to go back and make a new hypothesis and figure out what it is. Sometimes there's stuff I'm doing at home. If it doesn't work out, I'm just done with it. I don't care that much. Sometimes, like if you're trying to fix something at your house or on your car, you got to make sure it gets done. So you got to go back and form a new hypothesis and figure out what's going on. If supported, it's confirmed but not proven. In science, in real life, if you prove your hypothesis, you're probably done with it. If we're talking about cars or light switches or something simple, you're not going to go back and do this over and over and over again. In science, if it's confirmed, you've got to do additional testing. You've got to keep doing it to prove that it wasn't just a fluke, to get extra data, because not every test is going to come out exactly the same. So you've got to get a long list of data to make sure that your hypothesis is supported. A fertilized plant will grow taller than an unfertilized plant. You can do it with just one plant, but if it works, you want to do it with maybe 10, 20 plants, or do it several different times in a growing season to make sure that you're getting the right data down. So now, observation versus inference. Sometimes you will think things work out correctly, but it's not always what you think. For an example, light clothes versus dark clothes in the heat. I think we all kind of agree that if you wear a dark shirt, you're going to get hotter. If you wear a light shirt, the sun's going to reflect off of that. It's not going to heat you up as much, and you'll kind of stay cooler. But that's not always the case. If you go to, or if you look at videos of people in the Middle East, they have a lot of covering on, and sometimes, especially in the very hot areas, that covering is black. And so it's not always the case that dark things attract more sunlight and end up getting hotter. Sometimes with different materials and the way that you wear them, they can, the opposite effect can come true. So you want to make sure that you're actually testing this stuff and observing the results and not just thinking about what's going to happen and making up your own mind based on what your mind thinks. You want to actually do the experiment and get that information and make sure that it works out. So inference, we all know what observation is. Inference is the process of deriving logical conclusions based on observations. A ball rolls off the table and falls to the ground. Your observation is that the ball fell off the table to the ground. Your inference is that gravity acted on the ball and pulled it towards the ground. But you can't always trust that's the case. If the table is, I guess if the table's tilted, it's still going to be gravity. But if the table's flat and you have a fan right here, gravity wasn't the thing that pushed the ball off the table. It was the wind. And so it's not always the thing that you may think it is. Hypotheses are built from observations and inference. Now we move on to theories. We only got 5 slides left, so this shouldn't take too much longer. A theory is an explanation for a set of observations or natural phenomenon, like we talked about yesterday, that have been repeatedly confirmed through experimentation and observation. So don't think of a theory as something that we're not particularly sure about. Think of a theory as something we have proven. It hasn't quite moved into law because there might be new things that we discover. We might invent new tools that create a different situation that kind of makes this theory need to be changed. But in general, theories are proven correct and they are trusted. Keep your heads up. They're broad in nature, so they're not super specific all the time. Supported by considerable evidence. So we've gone through it and made sure that they work and they make sense. And then generated over a long period of time. Like, for instance, the plate tectonics theory. The idea that on the globe, your different continents are part of these giant plates that are essentially floating around not floating around in the ocean, but kind of moving around the earth in different patterns and different ways. That is a theory, but we know that it's true. There might be certain aspects of it that we figure out are different than we're thinking right now in the future as we get more tools. But that is not something that's like kind of up for debate. We're just trying to hammer out the details. When we get to atoms, they have the atomic theory. We understand how atoms work. It's not wrong. We just might find a better model or a better way to explain it in the future, so it's still classified as a theory. So they have a nice little flow chart here. Get used to seeing flow charts as you go through school. You'll see a lot of these. Workplaces use a lot of flow charts too. And so just kind of know that you're following the arrows, and sometimes you kind of got to double back. Sometimes you have choices on which way to go, but flow charts are really good. So you go from observation to hypothesis to an experiment. If your experiment works, you can move into a theory. If it doesn't work, you have to go back and form a new hypothesis and try to experiment again. Nice. So the theory of evolution is an example. We know that evolution takes place. Evolution has been proven. Do we know all the things about evolution? No. So that's why it's still considered a theory. It's not the law of evolution. We know that all living organisms on Earth share common ancestors and that they have changed over time through natural selection. I know that Cecil's probably talked to y'all about this. We have literally seen evolution take place before our eyes. It's not just something that happened in the past. It's happening today in many different animals. And so it is a proven thing. Describes a set of observations, describes the process by which evolution occurs, and it's tested in multiple different independent researches. So remember that theories can change, and that's why we still leave them as theories and don't call them laws. A law has been proven, it's very specific, and it's unlikely that we find something that just breaks it open. Where theories, you can find contradictory evidence, you can get new technology that makes you kind of reform your question or reshape the way that you're describing it. So they can be modified, they can be kind of torn up and rejected. In the case of plate tectonics, this guy got it right at the beginning. He called it continental drift, and he talked about how the continents moved around, but he didn't describe how it really worked. He didn't know how it worked. He just knew that it was happening. So his original theory got discarded and rejected, and we came up with a new one called plate tectonics, which is a little bit better than his other one. So sometimes they're modified, sometimes we scrap it and kind of start over. Scientific theories are supported by a considerable amount of evidence collected over a long period of time. So we already said that. And if a theory is around for long enough and it's specific enough, it can move into scientific law. A law states that a repeated observation of a behavior or phenomenon, it's not really subject to change a whole bunch, but it's more about observations. So like gravity is not a theory. If I hold this up and I let go of it, what's it going to do? Drop. Like gravity's not ever going to turn off. We might understand something different about it, but gravity is a law because gravity is always going to be here. It's not ever just going to go away. Oh, I didn't even know they were going to say that. This is my first time doing this today, so I did not remember that they were going to say gravity, but I got it right. Isaac Newton's law of gravity predicts the movement of objects, but it's not explained how or why gravity works. And to be fair, gravity, I think we got gravity down. There's a lot of stuff related to gravity and like atoms being held together that we kind of take for granted and have a really hard time explaining in detail. That gets into physics, but know that there's still a lot of scientific work to be done. So you go from observation to hypothesis to theory and then law. And notice there's more observations than hypothesis. There's more hypothesis than theory. And then when you get to the top with law, there's very few laws comparatively because there's not a whole bunch of things that we know just will never change. So a lot of stuff gets left in the theory category. And then you have scientific fact, which is kind of close to law. It's probably very similar. Must be repeatedly confirmed and objective. Scientific fact, laws, and hypotheses help generate and formulate scientific theories. And then we're done. So what we're going to do right now, everybody can open up their Chromebook. And you at home can follow along with this. I do have another video showing you how to do this, but if you want to, you can do it here with us right now. Actually, let me close this out. When you go to your Chromebook, you're going to come up here and hit this home button in the top left corner that looks like a house. It's going to take you to your ClassLink page, which I'm opening up right now. Come on. So it'll take you to your ClassLink page. If it asks you to log in, it will be your first name dot last name, and then ID number. Your password will be your ID number and PISD. So username is first name dot last name. Password is your ID number and PISD. That's just for ClassLink. So that's to get you logged in to see this part. So once you get to here, you're going to look for your folder that says textbooks. I have probably more stuff than y'all do, and your folder might be in a different spot. But you should have some folder that says textbooks. Is everybody logged in? Did everybody get to this? All right. If anybody gets behind, let me know. I don't want to leave you behind. Or I can come help you after I'm done. You're going to open up the textbook folder and find the sapling icon. It's the one that looks like a leaf. Remember, sapling is like a tree, like a baby tree, like y'all are baby people. Not baby people, sorry, but you know what I mean. Sapling, it's a tree that's growing up. It's getting bigger. It's learning to be a tree. So click on the little leaf icon. It'll take you to sapling. Now, you're not going to see what it's about to ask you to do. It's asking you for a username and password, right? So your username and password will be, let me turn the lights on. Lights are coming on. Yeah. You'll be all right. You'll survive. Your username and password is going to be in this format. It's going to be TX, like Texas. These are all lowercase. TX, PLM, like Palmer. This is your username. And then your ID number. No, wait, sorry. The first four of your last name. First four last name. Like for me, it would be BAIL because my name is Bailey. Yes.
May I use the restroom? I tried to hold it,
Yeah, hurry up, and then you can log in when you get back. TXPLM, BAIL, or the first four, your last name. And then at the end here will be your ID number. No PISD or anything, just your ID number. So I'm just going to put 1, 2, 3, 4, 5, 6. So no spaces. This is your entire username. TXPLM. First four letters are your last name, then your ID number, no spaces altogether. Let me write username. Your password is just your ID number. No PISD, nothing after it. It's just the numbers. So put that in, hit save, and it should take you directly to the sapling page and log you in. Did everybody get it? So on yours, just so we can fix it and go back to the ClassLink page.
Oh, I forgot his letter M.
Okay, wait a second. Before you do it, go back to the ClassLink page so we can fix it so you don't have to do it again. Double tap on that. Nope. Close that out. Hold Alt, and now click on it. Update password. Click on Edit. And put the M in there. Did everybody get logged in? Nice. Okay, now go ahead and click on it, and it should log you in automatically. That way you don't have to put in your password every single time. Okay, people at home, if you're having trouble getting logged in, please send me an email, and I will try to get you helped out with that. So I'm going to turn the lights out. Where are we at? My courses. Current courses, we have sapling. So it just says Palmer High School sapling chemistry. It doesn't have a date on it. It's going to take you to this first page. And what I'm going to do right now is assign the assignment, which will just take me a second. It's this hypothesis assignment here. I'm going to hit update. I'm going to change the due date to today at 11:59 p.m. Save and return to course. And so you might have to hit refresh. Hit refresh on your page, and you should see it right here up top. It should say hypothesis. You can go ahead and click on it and start on it. It's only 6 questions. If you have any questions, let me know. And just for y'all and the people online, if you scroll down now into chapter 1, you see the due date here next to the assignment. So that tells you that's what we're working on. If you want to watch the video, you click on the power lesson just above it. What is science? Hypothesis theories. So it has the names of the assignments right there in it. It will be like a lecture video like I just did. If you want the study sheet, this is all in section 1.2. You can click on this study sheet, which I'll probably put a link to. I'm not going to put a link in Classroom. But you can pull up this study sheet, and it kind of gives you like a bullet pointed view of all the stuff. So you have what is science, you have hypothesis, you have theories. This one's just, it's not 1 page, it's 2 pages. And then they got some more stuff down here. So if you like a little cheat sheet like this to help you out, you can use this. I'm never going to get mad at you for using this in class unless it's a test.
One of the teachers these students need to report to the gym at this time. Kiana Myers, Caitlin New, Daniel New, Cheyenne Newman, Connor Norman, Veradina Ojeda, Abigail Oliver, Joel Orozco, Jose Orozco, Natalia Ortega, Jake Osborne, Cameron Overgard, Emmanuel Pacheco, and Yamilet Pacheco.
Okay, you still got about 10 minutes left in class. So that should be plenty of time for everybody to finish it. So everybody be working on the assignment. Get going on it right now. For online people, please send me an email if you have any questions, and I will